Today we will discuss example 3.23. See the figure, this one. The top view of a car, single wheel steerable. This will rotate only. Three-wheeled car, motor car, and top view. This is body frame, XB cap, YB cap, and ZB cap going into the plane of board. This is fixed frame, ground frame. XS cap, YS cap and ZS cap is coming out of the plane of board. This motor car rotating around this axis, perpendicular to the plane of board, this way. See, this vector, this way, it is rotating this way, about this point, this way. This is the position vector. Arrow is here. This is the position vector of the body frame, origin, with respect to S frame. This one is RB vector. This one is RS vector. And here axis of rotation. The frame is this way. This one is X. This one is Y and this one is Z. See here, this is a stationary frame, fixed frame, this way. For body frame, if we rotate about y-axis this way, y-axis this way, about y-axis this way, 180 degree, then z-axis going to the plane of board. This is the body frame. This one is X, this one is Y, and z-axis is going to the plane of board. So we have rotation 180 degree about y-axis this way, about y-axis. So the rotation is 180. So RSB is cos 180, 0 sin 180, 0 1 0, minus sin 180, 0 cos 180. So minus 1 0 0, 0 1 0, 0 0 minus 1. This is the rotation matrix to convert the point or vector into S frame. RS, this one, position vector of this point where axis is located in S frame is 2, minus 1, 0. I have drawn the figure somewhat according to scale. See, this one X, 1, 2, and this one negative Y, so minus 1. And it is in XY plane, so it is 2, minus 1, 0. Now this is RB, this vector corresponding to B frame. So X positive, Y negative. And I have drawn this vector also according to somewhat scale. So it is X2 and Y is minus 1.4. It's given data, 0, RB. Origin of B, this one. So this vector is 4, 0.4, 0. This one. X 1, 2, 3, 4 and somewhat height. So 4, 0.4, 0. It is rotating about this axis at 2 radian per second. So omega S is 0, 0, 2. The car is rotating this way. So of course angular velocity is coming on the plane of board. Axis is here. So rotation angular velocity must be in this direction. But for S frame, X here, Y here, Z is here. So this is 0, 0, 2. Of course it is in this direction. But for this, XB cap, YB cap, ZB cap is going to the plane of board. But here it is rotating this way. So angular velocity must be in this direction. So it is 0, 0, minus 2 according to body frame. And the transformation matrix TSB transmission matrix of a body frame in S frame is RSB, PSB 0, 1. RSB is this minus 1, 0, 0, 0, 1, 0, 0, 0, minus 1. PSB is the origin of the body frame and it is given 4, 0.4, 0. And the rest last arrow is all are sorry, this one is 1. Okay. Now observe the figure. From the figure and simple geometry, see P vector already in S frame, RB vector is according to body frame and RS vector is according to S frame. So applying triangle rule, P plus this vector equal to this vector. P is arrow is here, RB for RB arrow is here. But RB is representing B frame, so we have to convert into S frame. So P plus RRB, R is the rotation matrix, equal to RS. This one, P plus RRB equal to RS, considering the vectors in S frame. So now multiplying both the sides by omega S, and I have written this side here. So omega S cross RS equal to omega S cross P plus omega S cross RRB. This one. So now multiplying both the sides by minus 1, minus omega S cross RS minus omega S cross P minus omega S cross RRB, because of, but the position vector of origin of S frame with respect to axis of rotation is minus RS. Axis is here and position vector of origin of S frame is this, so it is minus RS. So I have multiplied with minus sign, and this gives Vs because of here pure angular velocity, no translation velocity, pure angular velocity. Body's car is rotating about this axis, this point. Now Vs, this is Vs, is what? Omega S taking common, minus P minus RRB. So omega S cross minus 1 into P plus RRB. So omega S cross P plus RRB is RS. See here. So omega minus omega S cross RS. So we have confirmed. And omega S, we have given that 0, 0, 2. And what is RS? RS is this 2 minus 1, 0. So if this one, if we multiply cross product here, we get minus 2, minus 4, 0. This is omega S cross RS. So omega S, this one 0, 0, 2, and RS is 2, minus 1, 0. So cross product of these, but with minus sign is there. So minus into bracket 240. So minus 2 minus 40. It is the velocity of body's origin in S frame. Now VB is omega B, same sense, omega B cross minus RB, because of axis is here. So vector of this point is this opposite to RB. So omega B cross minus RB. So minus sign here, omega B cross RB. This one, and it is VB. Omega B is 0, 0, minus 2, and RB is 2, minus 1.4, 0. RB, this vector 2, minus 1.4, 0. If you cross product here, you can verify yourself. Minus sign is here already, and this one is minus 2.8, minus 40. So plus 2.8, 4, 0. This is the body frame velocity, linear velocity of the body's origin in B frame, 2.8, 4, 0. Okay. See the figure. The Vs we have drawn here. That means if we consider the car is at rest, relative velocity, then the body frame is moving this way, anti-clockwise, about this axis. See, this axis. If you consider the car is at rest, relative velocity, the fixed frame origin, is moving this way with angular velocity omega is 2 radian per second. So this must be at right angle to this RS vector this way. So if you want to find Vs, omega s cross minus Rs, and this gives Vs. So this confirms the theory exactly. This must be in this direction, and Vs is this -2, -4, 0. According to this frame, x is here, y is here. So x coordinate is also negative, y coordinate is also negative, and according to scale it is -2, -4, 0. Now here, using the general formula, velocity in S frame, body's origin in S frame is RVB, linear velocity of body frame expressed in S frame, minus omega s cross p. That is apparently velocity of the linear velocity due to rotation. Linear velocity of the body's origin due to rotation. We have to subtract it. Actual formula generally in book written this way. So actually the confirm this one is more comfortable. So RVB minus omega s cross p. So reverse RVB, if you order reverse the plus p cross omega s. So RVB plus p cross omega s r omega b. Now RVB, R is rotation matrix, VB is this, we have obtained already 2.840. So I have written 2.840 minus omega s cross p. Here observe the figure, angular velocity this way, so coming out of the plane of board for both the frame, but here z axis is this way coming out of the plane of board. So for S frame it is 0, 0, 2. Here z axis is going to the plane of board, but omega is this. So for this omega b is 0, 0, -2 to sense the direction. Now omega s is 0, 0, 2 and p position vector of the body's origin, which is 4, 0.4, 0. If you multiply this, first row this column, second row this column, third row this column, so minus 2.800, so minus 2.8, 0 into 2.80, 1 into 4, 4, 0 into 0, 0, the 4, 0 into 2.80, 0 into 4, 0, minus 1 into 0, so 0. And if you cross product, taking cross product, you can verify also. We get minus 0.8, 8, 0. So finally minus 2.8 plus 0.8, so minus 2. 4 minus 8, that is minus 4, and 0 minus 0 is 0. So this is the Vs, velocity of body frame origin expressed in S frame, -2, -4, 0. See here this velocity, and it is this -2, -4, 0. Now see the figure. Now we will obtain the VB, that is velocity of the body frame origin in B frame. This one is P vector expressed in S frame, this one is RB vector expressed in B frame, and this one is RS vector expressed in S frame. But we want B frame, so this we want to convert into B frame. So R transpose into P, this is already in B frame, so plus RB equal to, this is in S frame, we want to convert it into B frame. So R transpose into RS. See here, R transpose into P, this one, plus RB equal to R transpose into P plus RB equal to R transpose RS, this one. So RB equal to R transpose into RS minus R transpose into P. So RB equal to R transpose into RS minus P. Now we want to multiply it with omega b, angular velocity, because of we want to find VB. So multiplying both the sides by omega b by taking cross products with omega b. So omega b cross RB equal to omega b cross this one, R transpose into RS minus P. But we want here, see here, this body, that is car, is rotating about this axis, about this point, and this is RB vector, but we require minus RB. So if we take omega b cross minus rb, then we get vb. So multiplying both the sides by -1, this equation. So minus sign here, but here I have changed due to minus sign, p minus rs. Rs minus p is replaced by p minus rs. Now if we put omega b is 0, 0, -2, because of body is rotating this way. So axis of rotation coming out of plane of board. But for this frame, z is going to the plane. So it must be 0, 0, -2 cross r transpose. By chance here r is this, but transpose is also same due to some figures. So -1, 0, 0, 0, 1, 0, 0, 0, -1, and p minus rs. P is well defined, 4.40, and rs is 2 minus 1, 0. 4 minus 2, that is 2. 0.4 minus -1, that is 1.4, and 0. So it is -2, 1.4, 0. This one, sorry, 2, 1.40. And if we product these two matrices, we get -2, 1.4, 0, and it is 0, 0, -2. And if we take cross product of these two vectors, I have verified in rough work. So we get 2.8, 4, 0, which is minus omega b cross rb. It is the velocity of body frame origin in B frame. Okay. Again, we are discussing the same illustration, but as per textbook. See the single wheel steerable, 3-wheel car. It is rotating about this point, about this axis. We have discussed already. So car's motion be a pure angular velocity 2 radian per second about this point, about this axis, going into the plane of board this way, angular velocity. Here rs is 2 minus 1, 0. RB is 2 minus 1.40. Omega s is 0, 0, 2, and omega b is 0, 0, -2. We have discussed already. So simply we can represent Vs is omega s cross minus rs. Because of, if we consider this car is stationary, then this stationary frame is rotating about this, and this is the origin, and this is vector, so minus rs. So if we take directly omega s cross minus rs, if we take cross product, we get -2, -40. This one is Vs velocity, and Vb same here. If we consider here origin, axis of rotation here, so this vector is minus rb, and omega b cross minus rb directly, because of pure rotation is there, pure angular velocity, no translation. So 2.8, 4, 0, we can write directly. This is Vs velocity of the body origin in S frame, which is the velocity of body origin in B frame, and thus obtain the twist. Spatial twist is omega s Vs. Omega is 0, 0, 2, Vs is -2, -40, and body twist omega b Vb is 0, 0, -2, Vb is 2.840. For this transformation matrix, this transformation matrix TSB, body transformation matrix, TSB is RSB, PSB, 0, 1. RSB we have discussed -1, 0, 0, 0, 1, 0, 0, 0, -1, 0, 0, 0, and PSB 4.401. This is transformation matrix TSB. That is transformation matrix for body frame. We want to convert into S frame. For this we will use this. Now this using another formula to confirm these results, using the formula, spatial twist is adjoint representation of TSB into body twist, and adjoint representation of TSB is given by R0 skew symmetric of P. P is position vector of body of the origin of body frame with respect to S frame. So this one, and it is 4.40. This one 4.40 and this one. So R0 skew symmetric P into R into body twist. R is well defined, this one. but these we have calculated sideways. Skew symmetric of PR, it is skew symmetric of P is 0.4. You can verify according to the data. This side 0 minus 4 minus 0.440. If you multiply R, we get this one 0 minus 0.4004 0.440. So R is this. Skew symmetric PR is this one. This 0 and R is again this. And body twist is omega B VB 0 minus 2.840. So I have written here. If you multiply these two matrices, you can check yourself. We get 2 minus 2 minus 40. This is spatial twist, and already we have obtained 2 minus 2 minus 40. This one. So it works. So we can use directly. For computer work, it is more comfortable. Okay.